So, a very pleasant day to all of you. So, we are the Group 2, and I'm Ralph Kenneth M. Sano, the first reporter. And today, we're going to solve linear programming problems. So, these two problems are the ones that we will solve graphically. But let's start with the first problem. So, here, the objective function and subject to some constraints are already given. And since we already have the ST, now let's apply the idea on how we're going to sketch inequalities. So as for our first equation, we have 40x plus 60y is equals to is greater than or equals to 360. And as per graphing the inequalities, we will convert it to an equation for us to identify the 2 points that is necessary on determining the line. With that, we have come up with 40x plus 60y is equals to 360. Now to proceed, for us to get the 2 points, we will let the x and y to be equals to 0. So here we let x is equals to 0, and with that we'll have 40 times 0 plus 60y is equals to 360. And now we have 60y is equals to 360, and divide both sides with 60, and we will come up with y is equals to 6. With this, we have now already identified the first point or ordered pair, which is the 0 and 6. And now for the next one, we'll let y is equals to 0. So 40x plus 60 times 0 is equals to 360. And now we have 40x is greater than or equals to 360. Divide it by 40, and now we have x is equals to 9. So the second point will be 9 and 0. And as for our second equation, just like the step on our first equation, we let x is equals to 0, substitute it, and now we have y is equals to 4. With this, our first ordered pair would be 0 and 4. Now, let's substitute 0 to y. So much for that. We will come up with x is equals to 12, and our second ordered pair would be 12 and 0. Now let's proceed to the third equation. So we have 1600x plus 1200y is equals to 9600. Let's substitute 0 to the x, and with that we'll come up with y is equals to 8, and our first ordered pair will be 0 and 8. And now let's substitute 0 to y, and we will come up with x is equals to 6, and having an ordered pair of 6 and 0, and that is for our third equation. And that is for our first, second, and third equation. And we also have x and y is greater than or equals to 0, which is our non-negativity constraints, in which we will also include it in our graph.
I'm Wendell Laguna, and I'm here to explain what my groupmate has solved the equation. So in here, our first equation, as my groupmate solved that one, we have the 2 points, which is the 0, 6, and the 9, 0. So we just simply plot that one and let's try to get 10 and 1 if it will satisfy the inequality. So since it satisfies, our shading will be above the line. And so to continue, the next point that we have is 0, 4 and 12, 0. Just like earlier, we just need to simply plot the points. And now let's try the numbers 12 and 1 if it will satisfy the inequality. And as you can see, it satisfies the inequality, so the shading will be above the line as well.
I'm John Heyoy, and I'm the third reporter. So, as for the next one, this will be the last points that we needed to the plot in order to get the corner points of the vertices. So, as we can see, we have points 0, 8 and 6, 0. Just like earlier, we just need to simplify, plot it, and know if the certain numbers that we put X and Y satisfy the inequality. So here, we tried 7 and 1. And as you can see, it satisfied inequality, which leads the graph to be above the line.
I am Pledge Paglinawan, the fourth reporter, and we must not also forget the x is greater than or equal 0 and y is equal to greater than 0. After that, we can already proceed as we already have our corner points or vertices, which is the 0, 8, 3, 4, 6, 2, and 12, 0.
Good afternoon, everyone. I am Debon Pete Kasipong, the fifth reporter. So since we already have the corner points, we will use this for us to find the minimum cost. So what we must do is to simply substitute these values to our objective function. The first number represents x, while the second represents y. And as you can see, we have substituted the numbers. And what we must do is to identify the minimum cost which has the least number out of all the answers. So for this problem number 1, the solution set of the LP model is x is equal to 3, y is equal to 4, and cost is equal to 620 pesos.
My name is Charles Dominic Antig, the sixth reporter. So that is for our problem number 1. Now, let's proceed to our problem number 2. An iron bar producer manufactures two types of iron bars: galvanized iron bar and rust-free iron bar. A ton of galvanized iron bar requires 2 hours in the formation department and 5 hours in the soaking department. A ton of rust-free iron bar requires 2 hours in the formation department and 3 hours in the soaking department. The formation department is open 8 hours per day, and the soaking department is available 15 hours per day. The profit of a ton of galvanized iron bar is 4,200 pesos, and it is 5,000 pesos on a ton of rust-free iron bar. Determine how many tons of each type of iron bar should be made in order to maximize the profit.
I am Angelo Joshua C. Briones, the seventh reporter, and after reading the second problem, we must make a table to arrange things. This table will help us to make the problem to be solved easily, as it belongs to the process of solving linear programming problem. Now we are going to label things. For the formation department, the galvanized iron bar and rust-free department only requires 2 hours. The availability of the resources of the formation department is 8 hours. And for the soaking department will be 5 hours in galvanized iron bar and also 3 hours for the rust-free iron bar. And the availability of the resources is 15 hours. For the profits, the galvanized iron bar have the profit of 4,200 pesos, and for the rust-free iron bar have the 5,000 pesos. For us not to be confused as the process is needed, we need to let G the number of tons of the galvanized iron bar to be produced. Also, we must let R as the number of tons of rust-free iron bar to be produced. 4,200 G, profit of producing tons of galvanized iron bar. 5,000 G, profit of producing tons of rust-free iron bar. And for the total profit is 4,200 G plus 5,000 R. This objective function will become our model to maximize the profit that we need. And now we are going to have the ST. So what does ST represent? So ST represents as the subject to some constraints. So our constraints here are 2g plus 2r less than or equal to 8 in the formation department, and 5g plus 3r less than or equal to 15 in the soaking department, and g less than or equal to 0, r is less than or equal to 0. And now, a short reminder guys. So why we need to use less than or equal here? We need to use less than or equal here because this problem is locating for the maximum profit. If we are locating for maximum profit, then we need to use less than or equal.
Okay, so I'm Nico Arnold El Serino and will report for the topic slide number 11. So for us to find the coordinates, we need the g and r coordinates, and then we must have to use a certain method, of course. And let us use this in a constraint of 2g plus 2r less than or equal to 8, or 2g plus 2r is equal to 8 to find the coordinates. So first is in finding the coordinate of r, we must let r into 0, and then it will become 2r plus 2 close and open parenthesis 0 is equal to 8. Then it will become 2r is equal to 8. To cancel the 2, you must divide things into 2. It will become 2r equals 8 divided by or over by 2. The answer will be r is equal to 4. The coordinate will be close open parenthesis 0, 4, and then close parenthesis. In finding the g, we must let r into 0. This will turn into 2g plus 2 close and open parenthesis 0 is equal to 8. And then it will form into 2g is equal to 8. And then to cancel the 2, you must form it into 2g is equal to 8 over 2, and then solve. The answer will be g minus 4, and the coordinate is close and open parenthesis 4, 0. Next is we must use the constraint of 5g plus 3r is less than or equal to 15, or 5g plus 3r equals to 15. So first, if in finding the coordinate of r, we must let g into 0. It will become 5 close and open parenthesis 0 plus 3r is equal to 15. Then it will become 3r minus 15. 3r is equal to 15. To cancel the 3, you must divide things into 3. It will become 3r is equal to 15 over 3, and then the answer will be g minus 5. The coordinate will be 0.5. So in finding the g, we must let r into 0. This will turn 5g plus 2 close and open parenthesis 0 is equal to 15, and then it will form into 5g is equal to 15, and then to cancel the 5, you must form it into 5g equals 15 over 5, and then solve. The answer will be g is equal to 3, and lastly the coordinate is close open parenthesis 3, 0.
Verde Barantoy, the 9th reporter, and now we are going to grab the coordinate that we have solved from the earlier. So the coordinate that we have gathered in 2g plus 2r less than or equal to 8 are 0, 4 in y and 4, 0 in x. Also, we have tested the point whether it is true or false. So for the 2g plus 2r less than or equal to 8, we must let g and r into 0 and solve it. In here, we can define whether it is true or false. It will become 2, 0 plus 2, 0 less than or equal to 8. So the result will be 0 is less than or equals to 8. In here, we can define that the statement here is true. So, as like as the given constraint of 5g plus 3r less than or equal to 15, and also we need to again test the same process of testing. We must turn the g and r into 0. So of course, and it will solve it, and the outcome will be 0 is less than or equal to 15, and the statement here is true. So now We have done finding the coordinates, and also we have tested things that we need to test. We must now jump into the process of graphing. Here is the graph. It shows that the coordinates are being put in the graph. The 4, 0 and the 0, 4 are plotted. Also, for another coordinate is also plotted, 3, 0 and 5, 0. So the coordinates now, where every coordinate is plotted in the graph, and the points that is tested will help us to identify where we need to shade the graph. So as we found out that all is true in the test points, so we must shade this downward after we located the visible region right there in the PowerPoint presentation.
So I am Joshua Rizon, the 10th reporter, and as for this area, we must have to compute and locate for the corner point. So guys, please focus and still lend me your eyes and ears. In finding the GNR corner point, we must apply the elimination method. From the given 2g plus 2r less than or equal to 8 must multiplied into 3, and the negative 5g plus 3r less than or equal to 15 is multiplied to 2. We have done this because this will enable us to cancel the r. And now, let us now solve it to make things happen. After distributing things, it will become 6g plus 6r less than or equal to 24 minus 10g plus 6r less than or equal to 30 equals to negative 4g less than or equal to negative 6. To cancel the 4, you must divide it into negative 4g equals 6 divided by 4 equals to 1.5. Rg is 1.5. In finding the R, we must use the same method. The elimination method 2g plus 2r less than or equal to 8 times 5 minus 5g plus 3r less than or equal to 15 times 2. Then it will become 10g plus 10r less than or equal to 40 minus 10g plus 6r less than or equal to 30 equals to 4r less than or equal to 10. So to cancel the r, we must form it into 4r equals 10 divided by 4, and the answer will be 2.5. And now we have the r, which is 2.5.
I am Dave Pino, and we are almost done, guys. So we are now here in the process of collecting the corner points and substitute the values to the objective function. The corner points that we have gathered are 0, 0, 0, 4, 1.5, 1.5 and 2.5, and lastly 3, 0. Let's start solving the profit and take note. We must need to find the maximum one. For 0, 0 is P equals 4,200 times 0 plus 5,000 times 0 will equal into 0 profit because it was all multiplied to 0. For 0 and 0, 4 is P equals 4,200 times 0 plus 5,000 times 4. The 4,200 multiplied into 0 will become 0, and the 5,000 multiplied to 4 will become 20,000. So our profit here is 20,000. For 1.5 and 2.5 is 4,200 times 1.5 plus 5,000 times 2.5. Solving this into 6,300 plus 12,500 equals to 8,800. For 3 and 0 is 4,200 times 0 times 3 plus 5,000 times 0, as 5,000 times 0 will be equal to 0, and then the things that you will solve is 4,200 multiplied by 3, and the answer will be 12,600. So
For the continuation in the slide 14, as we gather the profit, we can now finally define what is the maximum profit. So the maximum profit is 20,000 pesos. And now the solution set of the LP model is G is equal to 0, R is equal to 4, and the cost is 20,000.
That is all for our report. We hope that you've understand it. Thank you.